Okay, so here we go. Um,
You know that kid in the front with his hands in his pockets? He was a really bad kid. And yeah, him. And he jumped on someone's head.
What? Who's that?
Avery's.
hopefully he's.
And then one time he got a gold star for acting how we all used to act, and he put it on the wall and started bragging.
What was his name?
So then I didn't have to work recently. Well, I don't know. It was just one night I didn't have anything to do, so I started stalking that, and I found his Instagram. Well, first I found his Instagram, and then it was private. So I went to he had his girlfriend's Instagram in his bio. So I went to his girlfriend's Instagram. She was private.
So then you could.
So then I went to her Visco link, which was in her bio, and I found pictures of him now.
Oh
my
god. No, but then everyone from that.
Then I requested him, and he declined all of us.
Why? There's not pictures now.
Oh my goodness. Okay,
Airdrop the pictures of Mal on the screen. Yeah.
not now.
I'll
Let's
send them.
go.
I'll send them in for next time.
I'd say just share it with your friends. I probably shouldn't put his picture on that. We've probably gone too far already, and it's already been recorded. Okay. All right, girls. Shh. So, when I gave you the IOU chart, I actually told you I'm not a big fan of it, but I'll give it to you. And now I realize that people are using a little too much without the understanding. I feel like you thoroughly understand what's going on when you use the 1, 2, 3 chart, but like people don't really know what's going on with the IOU chart. So we're going to talk about, and next year in calculus, you got to be really fast at like cosine of 2 pi is 1. Sine of 3 pi over 2 is -1. So you should just see it in your head. Like for instance, you know cosine is x over r, okay? So if the radius of the circle is 5, do y'all see in this direction cosine would be 5 over 5? My x-coordinate would be my r-coordinate at that moment in time. And over here, do you see why cosine's -1? That would happen at pi, 3 pi, 5 pi, all the odd pi's. And all the even pi's, I should know the cosine of 4 pi is 1. I should see it in my head. So I prefer this. Okay? If you're using the unit circle, your radius would be 1. And at this moment in time, x would also be 1. And so what would happen for like the sine of 0? Or the sine of pi? That should be 0 because there is no y-coordinate at that moment, is there? Do y'all all see what I'm talking about? At that moment, like right here, I can draw a triangle. But on these quadrantal angles, I can't even draw a triangle. I have only an x and no y. So when I think of tangent of 0, that's 0, not theta. When I think of tangent of 0, I'm thinking of y over x or opposite over hypotenuse. There is no opposite side, okay? So it would be 0. If I'm doing sine, isn't sine y over r? Okay? So up here at 90 and pi over 2 and all of those pi over 2, 5 pi over 2, 9 pi over 2. Every time you land at pi over 2, do you see your y-coordinate is the same as your radius? So the sine of pi over 2 is 1. The sine of 3 pi over 2 is -1. Tangent would be undefined. Okay? And you know that from your graphing. But look at tangent of pi over 2. Tangent, you know, is y over x. And as I head toward 90 degrees, I went from 0 degrees of having no y-coordinate to this point having only a y-coordinate and then no x. So hopefully you sort of just see that happen. That's how I do it. Okay? I actually do it with little points, like 1, 0, 0, 1, -1, 0, 0, -1. Does it really matter if I use 1? Can I use 3? And the same thing would happen. At this moment, I actually see my x-coordinate is the same thing as my hypotenuse. I like that a little better. But you have your chart. It's just that I feel like people haven't really understood what was happening. All right, now, next I wanted to talk about just something that's going to come up later in class, provided my voice lasts long enough for this to happen. Suppose I'm doing solve a trig equation, and I get something like this. And we're solving on 0 to 2 pi. So I go tangent theta equals 1/3, and tangent theta equals 1. Back to what Rebecca was asking me. If I've already been able to do the problem up to this point by factoring, then I'm okay with going ahead and finishing part of the problem. Tangent would be 1 at pi/4 and 5 pi/4. Why in the world would I type that into my calculator just to wait to solve when I already know the answer? Did y'all see what I mean there? All right, now, I don't know the tan of 1/3. So I have two choices here. I could push inverse tangent, or I could actually just look at a graph of it. Okay? Why is inverse tangent risky? How many answers will it give me? Inverse tangent? It'll only give me one answer, so I better be on my guard to get all the answers. Okay? So I've got the calculator pulled up. Okay. So I think I told you in the last class, I hardly ever actually push inverse tan, inverse sine, inverse cosine, because it's so risky, and it's probably not going to give me what I want. So I'd kind of rather look at this. I'll come back to that in a minute. So one option is, if I'm in radians, okay, to go second tangent of 1/3, knowing full well that all it's going to do is give me kind of a heads up. So I have a 0.322 radians, or 0.321. I would take either one. Let's call it 0.322 radians. That's right here. Somewhere in here. But isn't tangent also positive in this quadrant? So how can I find the other one? If this is 0.322, what is this over here? So how am I going to find it?
You subtract from 180. Or I mean pi minus. Yeah, minus 2. Plus 2. Plus pi. Plus pi.
Don't you want to go to pi plus 0.322?
Yeah. Yes.
Okay. I heard some minuses in there. So I want to go over to pi and go 0.322 more. All right, so then I can get my exact answer by going pi. Oh, darn. I didn't want to do that. So now I can go pi plus, and then I can go up there and grab this, enter, and I don't have to round off. And I get 3.463. Just side note here. As you all head into AP Calculus, this would have come at me like 3 tangent squared, like a quadratic. Y'all know what I mean? In AP Calculus, when you're on a calculator active part, you have your calculator half the time and you don't have the time. I wouldn't even risk factoring in solving. If I'm going to use my calculator, I said this the other day, I would use it in its purest form. The answer, in AP Calculus, if it's a calculator active problem, chances are you're never going to be able to factor it anyway, and you're just wasting your time, okay? Having said all of that, I would rather, and this is so important, I'm pausing because I can't talk, and also I want to make a huge point here. It's very risky to push inverse sine, inverse cosine, inverse tangent when you're not working on an inverse problem. I'm on a big tangent problem. So I'd rather actually see it like this. Don't I want to know every time tangent's 1/3 from 0 to 2 pi? A lot of people aren't looking right now. I don't know what you're doing on your computers. Don't think you need them right now. But I would actively look at this, okay? So right now I'm from -1 to 2 pi. If I hit graph, I'm going to change my window a little bit. I'm going to go from -3 to 3. Do y'all see I can see every time tangent equals 1/3? I'm not relying on inverse tangent to solve an equation for me that says tangent theta equals 1/3. So if you never want to push inverse sine or inverse cosine or inverse tangent to solve a bigger problem, you really could just leave the picture. Like if I'm looking at sine of x equals 1/5, I can look at it from 0 to 2 pi, and I can see them all on my calculator. Do y'all see the difference? What buttons would I have to push here though? Second, calc, what? Intersect. You've got to be close to the intersection before you hit enter, enter, enter. And I'm sorry that's in yellow, but can we barely read it? That's 3.463. And then I'm going to go back and find the other one.
Can you go back to the graph?
Well, right now I'm going to go find the other. Second, calc, intersect. I'm going to move back here. You just got to get kind of close to it and hit enter, enter, enter. And those are our two answers. Okay? All right, now, by the way, when you go to second, calc, intersect, don't always just go enter, 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 like I just did. Because later on, you might have 3 or 4 equations going through there. Sometimes you want to know where a couple of others intersect. So suppose I had this in here. Suppose I also wanted to know where tangent equaled 1. Okay? So if I want to find the values where tangent equals 1, I'll go to second calc intersect. I'm on the tangent graphs. Watch this. I'm going to hit enter. And then you can actually see what it jumps to. It just jumped to 1/3. I'm not going to hit enter yet because I don't want to be there. I'm going to hit my up arrow key until I land on the one I want before I hit enter. So if you have more than 2 equations in there, and this is just technology skills right now. I don't see you running into this on the test. But just to talk about how to do calc 0 and calc intersect, you will need it in AP Calculus. So just pause until you're where you want to be on your first curve and your second curve. Okay? All right, questions?
Can you clear your window for a second?
Girls, you always, 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 always logically adjust your window. Okay? You hardly ever stay on -10 to 10 anymore. Logically adjust your window. Think about what you're trying to see. Lindsay, question?
No, I just wanted
So if you feel like you can't see what you want to see, change your window, okay? All right, so those are a couple of things I wanted to say. Now, let's look at your homework for today. All right, I don't have the sheet in front of me. Oh, let me pause for a minute. And we'll take a moment later in class to write on your memo page. Please don't do that right now. I commend you for doing your homework when in 4 minutes I taught you, I didn't teach you anything. I just threw sign A plus B on the board and said, do your homework, okay? But you're brilliant, so apparently you did it okay. Sine A, cosine B, plus cosine A, sine B. Sine A minus B is sine A cosine B minus cosine A sine B. Cosine A plus B. Do you remember how I said cosine's always kind of the odd man out? It's the weird one. Do you notice in your homework maybe a little bit frustrating when you're doing cosine A plus B? What did you encounter in your equation? A minus. Did y'all notice that? Okay. Cosine A, cosine B, minus sine A, sine B. You don't have to write these down. They're on your homework page. You will have these memorized by the test. You should have had them memorized from doing your homework, which probably happens some, Isabel. I mean, you look at them so often. You should have them memorized. I will not give them to you. Now, I'm going to pause for a minute, and I'm going to show you where these came from in just a second, because you should wonder, like, how in the world would someone know this, okay? Common angles are 30, 45, and 60. Some other common angles are the 15s and 75s and stuff that you do in your homework, okay? I don't have those memorized. Sine of 15, I don't know. But I can find it with 45 minus 30 if I want to, okay? So please don't write this down, just watch. Unless you want to write it down, but you might miss something. Tangent A plus B, you could just get from this sine A plus B over cosine A plus B. Sine A plus B, sine A cosine B, plus cosine A sine B. Cosine A plus B is cosine A, cosine B, minus sine, sine. Somebody, don't know anybody's name, trying to find a formula for tangent A plus B, put sine A plus B over cosine A plus B. And then they decided to divide by one of these four things, okay? So let's divide it all by sine A cosine B. In fact, you could have picked any one of the four and it would start to collapse and reduce into something. This first fraction reduces to 1. What does this reduce to?
I don't know.
Wait, hang on. I may not have divided by the right one. Where's the worksheet? Let me see. Oh, I should. This one will collapse, but I wanted to divide by something else. Sorry. By the way, this one, wouldn't this be cotangent?
Yeah.
Tangent? So, I mean, what's happening here is you could add a formula with some of these things reduced, but it's easier to divide by a different one, sorry. You could divide by any of the four, and you would have it collapsed, but it would be better to reduce it this way. I'm going to divide by, which one? Here you go, pass it. Sorry, I divide by the bottom one, not the top one. And this collapses in a more convenient fashion. That gives you tangent A, and this cancels out. This cancels out, and this gives you tangent B. On the bottom, this gives you 1 minus tangent A times tangent B. Which, do y'all all see that on your page? Okay? So that's how they got this one. I still didn't show you how in the world they got those. Mr. Allen, I'm not going to ask you questions where you have to know tangent A plus B and tangent A minus B. I think what he does is he writes those two on the board or on the test or something. I'm going to show you today. I'm going to ask it myself in such a way to where you don't need them at all. Some of you may have thought about it when you were doing your worksheet. We'll talk about it in just a minute, okay? If you memorize them, you're welcome to use them. If you want to find tangent 15 by using the tangent A plus B and tangent A minus B, you're welcome to do that, okay? I find that I don't really need tan A plus B and A minus B in calculus, but I need the other ones. I gotta have you know the other ones. So therefore you have to memorize them, okay? All right, now, while I'm on that, well, I'll come back to that. All right, to save my voice, I am going to, well, first I'm going to do this. Hang on. One more thing. If I needed to find the sine of 15 degrees, and I never taught you how to do it, and we had more time in the last class, and I said, find the sine of 15 degrees. I wouldn't really fault you for going sine of 45 minus 30. But then you probably should have realized you were stuck, okay? Like for instance, what's the answer to that question? What's the answer to that question? 1. Undoubtedly, for sure, right? Would it work to say sine of 45 plus sine of 45? Sine of 45 is root 2 over 2. Root 2 over 2. That gives me 2 root 2's over 2, which gives me root 2. That does not work. It should not have worked. They don't have anything to do with each other. If you're thinking about how sine works with opposite over adjacent. Now let's try the little pattern I showed you in 5 seconds or less at the end of the last class. If I go sine A cosine B plus cosine A sine B, I get root 2 over 2, root 2 over 2, root 2 over 2, root 2 over 2. This gives me 2 over 4 plus 2 over 4, which gives me 4 over 4, which gives me the right answer. So do you see it does work? It's weird, but it does work, right? Okay. So now let's look at why it works. I'm going to only give you the proof right now of sine A plus B. I'm not going to go through the proof of any of the other 3, but it's just nice to see the geometry of where these came from. But I'm going to let someone else show you, provided the sound works on here. I don't want to talk through it.
Oh, this is Eric.
Yeah.
Is it like the cosine of A minus B? Is it like similar to like cosine of 90 minus X or whatever, and then sine X?
All of those, oh, you mean is it cofunction? They're not using cofunction.
Okay.
They're actually going back to
No,
similar.
like in the way that you said it, where it's like cosine A times cos times sine A? Is it similar to how, like, are they related? Like, you get. Never mind. I'll wait till the 16.
They may not be complementary, A and B. So I don't know if we're talking about the same things.
Okay. I'll just wait.
Okay.
Mrs. Eric,
Yes.
can I go to the nurse?
Yes. I hope the sound works. Girls, this lasts about 6 or 7 minutes, and I'm not going to play the whole thing. But did you see there's a link to it on Topics, so you could watch it? But I looked for one that would be similar to one that I would do that you could understand.
Hello, in this video, I'd like to show you why sine A plus B is equal to sine A cos B plus cos A sine B. Now, before we begin, please take a look at this diagram here to your left and see if all its contents are correct. If you're satisfied with this drawing, please continue watching this video. Now, the first thing we need to know is what is
You can kind of see it.
sine A plus B. So we're going to put
I'll see these
opposites
similar
over
triangles here.
hypotenuse. Now if you look at the triangle OPR
This is going to be A plus B.
and look at this angle here, we can see that this angle is A plus B. We can see that the opposite side is PR. So we're going to put PR here. And we can see that the hypotenuse of this triangle is 1. So we're going to put 1 here. So we know that sine
And like I said, I'm not going to show you the whole
A
thing,
plus B
but in interest of time, let's move on kind of toward the end.
F.
And he kept doing similar triangles. So that's all your geometry.
Okay,
It's a bunch
now
of
that we've got
geometry.
everything we need, we can prove that sine A plus B equals sine A cos B plus cos A sine B. We can prove this by saying that PR is equal to PT plus QS. Now, let's look at PR for a moment. PR is this line that goes all the way down
And
to
so
the
he's done
line
all of
F.
this
It's perpendicular
SOHCAHTOA
to the
stuff.
line L.
And then
Now,
he added
PR
it's
is made up of PT plus
the
TR.
angle addition.
But we can see that
Segment
TR
addition.
is the same length as
And so
QS.
that's how they do it.
Therefore, PR equals PT plus QS. And because of this,
All right. So again, you could watch that on your own if you want to see where the proof came from, because it'd be easy for you to understand all of the opposite and adjacent hypotenuse that he went through in the segment addition postulate. Each one of those is derived from something like that with similar triangles. Okay. So you need to know where they came from. For sine of 15 on test day, I'll see some people go 60 minus 45, and I'll see other people go 45 minus 30. You'll get the same answer. You'll be using different numbers, but you'll get the exact same final answer, okay? Which I guess that one was the square root of 6 minus square root of 2 over 4. Did you have sine of 15 on your sheet?
Yeah.
Wasn't that one square root of 6 minus square root of 2? All over 4. Whichever way you did it, okay? You felt like a lot of your answers had square root of 6 minus square root of 2 or square root of 6 plus square root of 2 over 4. If you felt that way, you were doing it right, okay? All right, let me answer some questions before I go on.
For the use of the first 4 that we do for the sine, the cosine could be like derived from the triangle. Could the tan be derived from the triangle, like from similar triangles? As
I
well?
haven't seen it,
Or is
and
it
to me
just-
it's not necessary because I can prove it with
So
that.
it's just okay.
Yeah.
So it's just the other.
You
4
might,
triangles.
I imagined you could find one. I just haven't ever felt like I even needed to look. Because once I have those, I can get the other 2. You get tangent A minus B, similar, and divide by the lower left, not the top left. Okay?
Would questions like these be on the memo page where you don't have your calculator?
You would not have your calculator for these. Because what? Even if you did, y'all are smart enough to realize you could figure out what the decimals are that match with square root of 6 minus square root of 2 over 4. So you're not going to have your calculator. Okay. All right, now let's look at cosine of 15. Cosine of 15. I'm going to do it with cosine of 60 minus 45. So I'm going to go cosine A, cosine B, plus sine A, sine B. Cosine is an even graph. The signs are different than what you expect them to be. Cosine of 60, cosine of 45, sine of 60, sine of 45. So I get square root of 2 over 4 plus square root of 6 over 4. And then somewhere on your sheet was tangent of 15. What number was tan of 15?
1 minus root 3.
No. I'm sorry, what number on the sheet?
Oh, number 2.
Number 2. Okay, well then I wouldn't do that probably on the test, but even if I put that as number 2. If this is number 2 on your test, I would just let it sit there for a minute and just save it. Because somewhere on that test, I'll ask you for sine of 15 and cosine of 15. So I don't know if anybody thought while you were working, but if you want to find tan of 15, you could just wait until you know sine of 15 and cosine of 15 and put the sine of 15 over the cosine of 15, which is going to be this. Okay? And you can leave square roots on the bottom. Okay? All right, now let's look at how you probably did tangent of 15. Unfortunately, some of you may have chosen tangent of 45 minus 30. And then you had complex fractions, which I will not accept. So tan of 45, tangent A minus B is tangent A minus tangent B over 1 plus tangent A times tangent B. And that's not acceptable to leave it like that as a complex fraction. So I'm going to multiply the top by 3 and the bottom by 3. That gives me 3 minus root 3 over 3 plus root 3. If you'd been lucky enough to do tangent of 60 minus 45, which in a slower paced class we do more of these, I would instruct you not to use 30 if you don't have to for tangent. Because what's the tangent of 60 is not a fraction. If I go tangent of A minus tangent of B over 1 plus tangent of A times tangent of 45, which is 1, I was good to go. Now as a teacher, I'm going to have to check any one of those 3 answers, right? If I ask you tan of 15. But what should happen if I punch this one, and this one into my calculator? It'll be the same thing. Okay? So here's what I suggest. Here's what I suggest. I suggest a lot of things, actually. Okay? So, Pietro, just save your question for a second. If you see tan of 75, you can use these tangent formulas should you choose to. Okay? But I would just wait until I find sine of 75 and cosine of 75. I would look through my test and see if I've already found them and put them over each other and fix it up. All right? Now, your worry should be, what if you missed one of those? then you're gonna miss that one, right? I won't double count off. Draw arrows to where you're getting your answers from. And if you miss it there, I won't count off again. I'll give you credit for putting sine over cosine, which is very much how they grade AP exams. Okay? Now, if I then ask you for tan of 105, look at this. Did I do 165? All right, watch this. 165 is right here. What kind of reference angle is that? 15. So it should be the same as, let's say, this answer. Except for what will tangent be in the second quadrant? Negative. So you could have made it negative of whatever your answer was. Watch for stuff like that, okay? If I asked you for the sine of 15, and then later I wanted the sine of 105, here's 75. Somewhere on your sheet you have sine of 75, which is square root of 6 minus square root of 2 over 4. Okay? There's all sorts of things swimming around on this worksheet that you can take advantage of. Here's sine of 75. Here's 105. They have the exact same answer. What's sine in the first and second quadrant? Positive. If you look at your sheet, those are the same. There's more swimming around on your page. Look at the cosine of 15 and the sine of 75. Cosine of 15, can y'all find it really fast? Cosine of 15? And the sine of 75? Because what should the cosine of 90 minus theta be? What do these add up to?
9.
Those are complementary. So if that is, you have cosine of 15, it should be the sine of 75. You could use any of those identities, facts that you want to. Granted, you might be kind of scared to. You might think, well, I'm going to go in and work the problem. But if you're in a hurry, it's really cool to notice that. Okay? All right, now, before I answer Pietro's question, well, let me go on and answer it. And let me say a couple of things. So I'm just writing notes to myself of things I want to remember to do, and I just forgot one of them. I don't know what it was. Shh, quiet. Thanks. All right, Pietro, question?
So I'm just kind of confused. So for one of the answers, let's say we were doing it before for 10 and 15, I got like 3 minus root 3 over 3 plus root 3. But in this case, would it be okay to leave the root on the bottom?
Yes. You can leave the root on the bottom. You can't leave a fraction inside a fraction.
Oh, okay, got it.
Okay? Hey, girls, if you're practicing things that you don't have the answers to, or last night, hopefully some of you thought I could check my answers. You can actually put your calculator in degree mode. Did I give you any radians?
No.
Okay. And you really, really must be quiet. Shh. Maybe the talk's good. I'm going to do a radian one. And we'll do some more on Friday, okay? What's today? Yeah, Friday. If you're practicing for the test, or you were doing your homework last night, you could put your calculator in degrees and punch in sine of 75. And then you can put in your answer and see if they're the same, right? Use parentheses. All right, 2 things I wanted to say. So in answer to Pietro's questions, you can leave square roots in the bottom.
So when is it not?
the back of the book, which you're not even looking at right now, wouldn't have rationalized it. I'm going to post the answers to this worksheet so that you have all the answers. And then you can like email me if you have like a different, or come by and see me if you have a different answer and say, is this okay? All right. Another thing is, what would you do for the sine of, let's say, 3 pi over, I do that. You'll come up with 2 radians that you know. Like I could do, I don't know pi over 12, okay? I'm trying to think if I can even do this one.
Yeah, can't you simplify to pi over 4?
Sorry. Yes. Certainly. If I gave you 3 pi over 12, go to pi over 4. Okay. 5 pi over 12. All right? You could do 2 pi over 12 plus 3 pi over 12. That gives you the sine of what? Pi over 6 and pi over 4. And then you can go on with your life. So I'll only give you radians that you could come up with. And we'll do some of those on Friday. Okay? Now, we're going to go to something like this that you're going to do your homework on for tonight. You have very few homework problems. Sine of 2a. These are called the double angles. Okay? They're super duper duper important in integral calculus in Cal 2. Sine of 2a, I can easily derive it based on what you already know. Wouldn't it just make sense to make both of my angles the same thing? And use the angle, the sum and difference formula. Sine of 2a is sine of a plus a. I've already sort of done it today. I did 45 plus 45. All right, so I'm going to go, according to the formula, you take sine of the first one, cosine of the second one, plus cosine of the first one, sine of the second one. But now what's the second one also? A. So do y'all see that those are the exact same statement? So I get 2 sine A, cosine A. Okay? Hopefully you would never think this in a million years. Please don't ever do that. But there's no way that should work. I shouldn't be able to factor a 2 out of that, first of all, anyway. But you've got to know that lots of people try to do that. You know, I'm always thinking about graphs and pictures. This is affecting the period of the graph. What is this affecting? The amplitude. There's no way that's going to work. It's pretty cool that that will work. I would have never dreamed it had I not proved it, though. Right? That'll work every time. All right? So, for instance, if I forget the sine of 90 on a quiz, I could say that's the sine of 2 times 45. And I can go 2 sine 45 cosine 45, where this is A. I can say 2 sine A cosine A. Let's see if it works. On the top, I get 2 times 2. And on the bottom, what do I have? Did it work?
Yep.
Okay. All right, so we'll talk about how you would use those. Here it is.
You know, when you're like going next to your ears are just popping.
Yeah.
But I can like half here. No, it's seriously. I think that's a lot of your eyes. What? Can it really? What? That's what I always say.
Girls, shh, quiet. Thanks. Before I work this problem, I gotta show you something else. How are we gonna find cosine 2u? Or cosine 2a? How am I gonna prove that one? A plus A. All right, now I know you don't know those formulas very well yet, but you go cosine, cosine minus sine, sine. Cosine of the first one, cosine of the second one, minus sine of the first one, sine of the second one. You get this cute cosine squared minus sine squared. Okay? So sine squared plus cosine squared is 1. Cosine squared minus sine squared is cosine 2a. If you type this into your calculator, you'll get a picture of that. Okay? But we can't stop there. I hardly ever use that formula. I like to morph it into one of these. No. No. No, no, no. No. Hang on. That's not -1. The reason I'm going no is people do that all the time. It would have to be negative cosine squared minus sine squared. It'd have to be a complete opposite. So don't put those together in your mind. They're just kind of two cool things about them. Okay? I'm going to change cosine squared to 1 minus sine squared. So I'm going to have 1 minus 2 sine squared. I feel like that I've lost y'all. I need you. I know there's a lot going on in the room besides over here, but I need you. Did y'all see I just subbed that in and I got this? I could also come to this. For sine squared, I could put in 1 minus cosine squared. That'll be plus. So you get this.
When you distribute the negative sine squared a, wouldn't it be negative sine squared a minus sine cubed a?
These were subtracted.
No, I know. And then after that, when you plugged in, I get the cosine squared a. And then when you have 1 minus sine squared a minus sine squared a, how does you get?
There's minus.
Oh! Oh, I was thinking of it like you're multiplying it by a negative.
These are subtracted.
Okay. Oh.
Okay, girls, in addition, sorry, it was so hard for me to talk, I don't know if I got far enough. Along with your homework, there'll be a little bit of a video where I'm explaining more of this. And then Friday will be just total review, okay? But during the video that I send you with my broken voice, we'll also write on your memo page, so make sure you at least listen to part of it, okay? I'll do some homework examples.